Today we're going to be playing with Docker Compose, and we're going to orchestrate multiple container images. In advance of the exercise, you'll want to install Docker Desktop and Visual Studio Code. You'll note in a previous exercise we talked on Docker, and we talked about making Docker files in order to define an image that you can spin up one-to-many of. Now we're going to talk about a solution for how do you orchestrate multiple Docker files or multiple Docker images through something called Docker Compose. Got a playground directory created for today's exercise, and I've got it open in a terminal instance. Next, we'll just open that up in code. We'll want to create a new file. We'll call that dockercompose.yml. It's a YAML file. You'll note immediately Visual Studio Code knows we're talking about Docker Compose here. It's got a fancy little whale. In this, I'm going to enter the following text. I'm going to define a set of services in which we'll have something called Redis. We'll have a Redis image. And that Redis image is just going to pull the Docker Hub image Redis. We'll save this. And then back in the terminal instance, we'll start running that. We'll run that through running Docker Compose up, just in the directory. If there's a Docker Compose file named as such, it will intuit that that's what we're talking about. And we'll see that it's running already. That's great. If we go over to a new tab, we can do docker ps-a to see all of the running images. And we'll note we have a Docker Compose Redis 1 image that is running as of 8 seconds ago. We can actually attach to that image as well. Since we know it has a name, we can docker exec-it. And then we can just go to the name. It's Docker Compose _ Redis _ 1. And then we can run the Redis CLI to attach to that. And you'll note we're in a Redis instance now, connected via the Redis CLI. We can do keys star. Note that there's no keys in it yet. Set day to non-zero, like we're prone to do in this channel. Now we have a day key. We can get day. And we have non-zero. So this is a Redis instance, and we've connected to it. All we had to do to spin it up was to do that Docker Compose up. And if we go further to clean up now that we're done with that, we can Docker Compose down. And again, it's going to intuit that we're talking about the one Docker Compose definition that's sitting in the directory. And it'll remove that image and remove the network that it spun up as well. We can talk about that network in a little bit, but if we do a docker ps-a, we'll see there's no image running anymore. That's great. What if we wanted to use a Docker file instead? Well, let's build one real quick. Create a new Docker file in the main directory. In that, we're going to have the complex code of from Redis. Like we've just pulled previously here. It'll just do the same thing, but in a Docker file. We can create a new Docker Compose definition, and we'll name it something a little different. We'll name it -docker file. It's a little bit different. Within this, we can then say something like Redis, and within that, the context so that we have the Docker file with a build attribute here. This build property will say, hey, we're actually working with a Docker file instead of a Docker Hub image or a container registry hosted image. So it's going to build the Docker file in the context of the directory given, which is just going to be this Docker file. If we do Docker Compose and we specify with F the new Docker file we built, then we can say up, and it'll build that Docker Compose image, that Docker Compose Docker file image. Targeting this Docker file, we'll get a Redis instance. And we can go through the process again to test that, which would just be to do what we did in the previous exercise, the keys, set, what have you. I guarantee it's working based off what you're seeing here, that it's created a Redis instance. You'll want to remember to clean that up as well. So if we just hit the up key, pull up the previous command, we can change up to down, and that'll clean it up as well. Let's imagine you have a need for a database as a developer. You don't want to necessarily touch your production database when you're in development, So as a developer at dev time, you might want to spin up a database that has the matching schema, looks like has the right tables or what have you, for whatever service or application you're building. So Docker Compose offers a development workflow that will help automate that quickly. That's what we'll work on next. I'm going to define a Postgres Docker Compose orchestration that's pretty generic and allows you to spin up what is your schema for your application. Let's start by creating a folder, SQL. In that, we're going to store some SQL stuff, such as an init.sql file. Within init.sql, we're just going to create our non-zero database. We've done this in a previous Postgres exercise. So we're going to use the non-zero database again. The next thing we're going to want to do is create something alongside that for pgadmin. If you'll remember in a previous exercise, we've looked at a Postgres database with pgadmin. It's a tool for navigating, browsing Postgres instance. This is going to be a definition for what to tell pgadmin about the Postgres instance we're going to be creating. So we're going to call it pgadmin_servers.json. In this, we're going to define some servers, just the one that we're going to be making, but we can quickly define that here. There's going to be some attributes we care about, like name. Just going to label that. That doesn't really matter, but it's a Docker Composed instance, so we'll use Docker Compose. A group that'll be in. That's like local servers. The port that we care about. Postgres typically is 5432. I'll just keep that. The username. We like secure things, so we'll just name it Docker. The joke is that that's not particularly secure. Postgres, SSL mode. I'm just going to prefer it. And what's the maintenance database? That's Postgres. Now we've defined a server for pgadmin to be able to say, hey, this is a configured thing. We'll use that in a Docker file shortly. Now the Postgres image and the pgadmin image we're going to be playing with have a variety of environmental variables that they care about and specific volume mappings that they care about. So I'm going to jump ahead just to show you what a definition is going to look like, a Docker Compose definition is going to look like for pgadmin and for Postgres. And we can walk through some of these, but specifically why pgadmin default password or what have you has to look the way it does and exist as this keyword is because of the definition of the Docker Hub hosted image that we're going to leverage. So to learn more about why specifically these keywords matter, you'll look up the image on Docker Hub. But effectively, we're spinning up a Postgres instance. We're going to pass this username, this password for that Postgres instance to be the default user password. I'm going to tell it, hey, here's the init SQL. We're going to pass that in through volume mapping. And hey, here's the pgadmin servers definition. So I want you to connect to our Postgres image here for these specifications, for this definition. And then when we do Docker Compose up, we'll have a pgadmin instance that depends on our Postgres instance. And then we can navigate to the pgadmin instance to see what the Postgres instance looks like. And a reminder that the GitHub repository associated with this video, this exercise, linked in the description below, will contain the text for these files. So if at any point you feel like you want to just navigate to that, grab the text from there and implement it as a way to shortcut that, perfectly fine. The goal is to learn how the Docker Compose engine works more than the nuances of a specific image. All right. Fixing a little typo here I just noticed. pgadmin4 to match here. Now we can do a Docker Compose up, specifying the file. This is the Postgres instance, that Postgres YAML. Do Docker compose up there. And then when it runs, we should see we start up our Postgres instance. It sees our entry point, which is good, so we create a database. Next thing we hope is that pgadmin starts up and that it targets the correct servers.json. And it looks good. We're loading up some server groups. That's good. All right. So now we can open up a browser instance to localhost 5431, and we'll see our pgadmin. Opened up localhost 5431. It automatically navigated to /browser. We're going to enter in our password of Docker that we specified. And note we have local servers as a group already defined. That's the group we specified. And now it says, oh, hey, you want to connect to those? Well, you need the Docker password, very Docker. And now we have databases in which you can see, hey, non-zero's there. We have our non-zero database. That's the one that we specified in init.sql. That's a sign of success. That's partway there. That gets us a server and a database. Next thing we'll want to do is get a schema, so get some tables in there. I'm going to do a Docker compose of the Postgres definition down that so that it cleans that up. And then we will iterate over here in our Visual Studio Code instance to add Flyway and some SQL scripts, at least one, to be able to define a table. If you followed the Flyway exercise before, you'll know we're going into SQL. We're going to make a v100 2 underscores table.sql. This will look familiar based off that previous exercise. And within this, we'll have create extension if not exists, UUID. This is just copying the code that we wrote in the previous exercise to generate a non-zero table, just with some stuff in it, a few properties. ID as a primary key, which is defaulted for that UUID. Oh goodness, I already have a typo. That UUID generate function that we used before. We're going to do name text, not null, age int, not null. I think we went further than that before, but I did the wrong kind of brackets. There we are. There's our non-zero table. And the next thing we'll do is we'll modify our Postgres instance. We're going to add Flyway to that. I'm going to jump ahead to that as well. In the Flyway exercise, we learned about Flyway migrate as a command and gave it some locations and said, hey, here's your retries, here's where the instance is at. I believe we targeted a URL before. But in this case, because Postgres is defined here, we can use that as a keyword, writing the port that we care about. And we can utilize the volumes, volume mapping to pass along our SQL files here. And if it sees v1, a versioned script, it'll run that. So we're going to use migrate to run on the Flyway SQL volume. And that should hopefully target Postgres as soon as it becomes available. Let's do a Docker compose up next. All right, let's run our Docker compose up. Using the Postgres definition, you'll note we have all sorts of stuff happening. We had our Postgres instance get spun up, Flyway started, and it said, hey, we're going to retry because Postgres wasn't ready. And that's because of the connect retries definition that we had. Close that. Yeah, the connect retries equals 60 says Flyway will just keep trying until it can. And then we see successfully applied one migration. And then Flyway exits. It says I've done my job. I just ran my command. That's all I cared about. Then pgadmin steps in and says, hey, we added our server we want to be able to communicate with. So we should be able to now open localhost 5431 and see in pgadmin our schema. All right, we're back at pgadmin. Let's enter our password. It's Docker. go to local servers. Oh my goodness, more password. Within that we have our databases, we have non-zero. And we're hoping the schema is going to be there. Tables, we have non-zero table. That's great. That's exactly what we were hoping we would have. We can do things like count rows or whatever. There's nothing in it. That makes sense. It's just the columns, ID, name, age. That's what we specified. That's great. You'll want to remember to clean up your Docker resources that you've created. Do a Docker compose down on that definition to remove the images in the network. Once again, you'll note a network is created every time we do a Docker compose up that connects each of the, by default, it creates a network if you're not specifying one, which you can do, but it connects the images within the definition. So you've got a Docker network connecting these three images. Once that's all cleaned up, there's only one more thing that I really wanted to touch on today, which is health checking. So you'll note right now, Flyway is waiting on connect retries. That's how it's playing with Postgres. That's how it knows, hey, maybe now's the time. Hey, maybe now's the time. It just keeps trying until it's ready. But in this case, we can actually implement something called health check on the Postgres instance, on that image definition. And we can say, hey, health check. We do a test. And since this is Postgres, we can do something very Postgres specific. We'll use command shell to run the command, the test. We'll say pg is ready -u Docker. So we're specifying the user as Docker, running the command pg is ready here. We'll do that with an interval, maybe every 5 seconds. Timeout, 5 seconds. We'll retry that maybe 5 times, like the number 5. And then we can say when we're doing a depends on Postgres, we can say, hey, actually, it's not just that we depend on Postgres, it's that we depend on Postgres with a condition that its service is healthy. So it depends on Postgres condition service healthy. Well, let's see what happens when we do a Docker compose up now. We'll do it wrong because I think I was supposed to specify it as such. If I read what I type, sometimes it goes better. There we go. So now it's trying it out. It says, hey, instead of the Flyway starting up right away and then doing a retry, we see Postgres becomes ready and then Flyway tries. It says, oh, hey, wait, Postgres is done. Now I can try. And that's that notion of depends on and condition, service healthy, and the health check being tested as such. Friendly reminder, go ahead and clean up your resources when you're done. Today we touched on something called Docker Compose. That's a way to orchestrate or organize multiple container definitions, multiple images within Docker, and have them all able to interact with each other or independent of each other. We talked about health checking as well. We spun up a Postgres instance and we iterated on its schema, and we were able to connect to it through pgadmin, all within a single definition file. Make sure to check out the description below for some of the links, including the GitHub repository that has all of this scripted out, all of these files as well. And if you have additional time, you can look at some of the documentation that I'll share. If not, congrats on a non-zero day.